Hello everybody. In this video series, I want to go and develop a cross-platform object detection using TensorFlow Lite. And let's start by discussing shortly what it means cross-platform object detection. So assume that we have our Android and iOS application and we want to run object detection. So we can use TensorFlow Lite libraries that we have for Android and for iOS, but then we will have to write the object detection code twice. And instead, we can write the object detection code in C++, and then we can use this C++ code in both Android and iOS, as both platforms support running native code. And we can also run this object detector in Windows, which we are going to do as our test application. This object detector in C++ is going to use the TensorFlow Lite C API. And of course, that for each platform, we will need to build the TensorFlow Lite library. So for Windows, it's going to be the TensorFlow Lite C DLL. For Android, it's going to be TensorFlow Lite C. And for iOS, there is the TensorFlow Lite C framework. And of course, we will also need some object detection model, which is a TensorFlow Lite model. So we are going to convert some object detection model from TensorFlow to TensorFlow Lite. This is what we are going to do in this series. In this video, we are going to do the conversion of an object detection model from TensorFlow to TensorFlow Lite. In the next video, we are going to write our object detector in C++, and we are going to test it in some Windows application. And in the third and fourth videos, we are going to integrate our object detector into an existing Android and iOS applications. So this is what we are going to do. And with that, let's get started. Okay, so the TensorFlow Object Detection API is actually in this repository. It's TensorFlow/models. And here under research and object detection, we have the TensorFlow Object Detection API. Now, we are not going to develop our own object detection. We are going to use an existing model and just convert it to TensorFlow Lite. And in order to do this conversion, we will still need to install the object detection API. I'm going to work in a Linux environment. This is WSL, Windows Subsystem for Linux, and this is a fresh install. So I'll start by updating apt. So we have the latest repositories. And Python 3, the Python version is 3.8.5, and do I have a pip here? No, so let's install it. Okay, installed. If we take a look, so we don't have TensorFlow here, so we're going to install TensorFlow as well. TensorFlow. Okay, this is going to take a while, so I'll be back when it's finished. Okay, it's finished, and now I'm gonna close my tabs and I'll start a new session. So I'll close this and start another session. And the reason that I installed TensorFlow is because it comes with this TFLite, convert script that we are going to need. And let's just see that we can import TensorFlow, so everything's okay. Okay, so this is installing TensorFlow. Now we're going to install the TensorFlow Object Detection API, and there is actually a very good installation instructions. So under TensorFlow 2, the Object Detection API. So we need to clone the repository. This is the first thing. So again, this repository is big, so I'm going to pause here and get back when it's done. Okay, and now we are not going to do the Docker installation, we are going to do the Python package installation. So I'm going to run these commands. Models, research, and then we need to compile some protobufs. So let's see. This is the protos, and we need the protobuf compiler, which I don't believe I have. Proto-C. No, so I'll install it. This is a quick installation. And okay, it's there, and now we can compile the protocols. That's it. Let's take a look. Okay, we got this Python files, so it's compiled. And now we need to copy the setup file. And once we have the setup file, we can install all the packages. We can install it as if it was a pip package. So we are going to run this. Of course, Python 3. Okay, now it's going to install a lot of packages that are related to the Object Detection API, and I'll be back. Okay, I got some compatibility errors, but it shouldn't affect us too much. And if we look at the packages we have here, so it's installed a lot of packages, and the packages that we want to see that are here is this object detection. And the reason that we installed this entire object detection API is just to use a single script that you will see soon. So our installation is completed. We are not going to test the installation because we are not going to actually develop using the object detection API. The next thing that we need is a model. So there is a model zoo for with many models for object detection. Note that that we are using the TensorFlow 2 detection model zoo, and we are going to use the SSD MobileNet V2 FPN Lite, and you can choose either the 320 or the 640 by 640. So I'm going to choose the 640. Of course, you can use any other SSD MobileNet. Now, whether it supports other models, I'm not sure, because we need to convert this model to TF-Lite, and TF-Lite doesn't support all the instructions from the different models. So I do know that it works well with MobileNet. I'll copy the link, and let's create a folder for the models, and download the model. Okay, and untar it, extract verbose zip file, and let's rename. So we'll keep everything but this, and we can delete the zip file. And inside the model, we have the pipeline config of the model, and the actual model, which is under saved model. This is the model. It's 9.2 megabyte. Okay, so we got the model, and the first thing that we need to do is to export this model. Like, we need to prepare it for conversion to TF Lite. And I'll go back to the documentation here, and there is the documentation about running on mobile. Here, running TensorFlow 2 detection API models on mobile. So the first thing that we need to do is export the TFLite inference graph. And we are going to use this script, which is the reason that we installed the entire object detection API. So from the TensorFlow model research directory, this is where we are, the models research directory. We are going to run. So we need to provide the pipeline config, which is the pipeline config, and the checkpoint folder. This is the checkpoint folder and output directory. Let's create an output directory. We'll call it SSD export. SSD export. Of course, Python 3. Okay, it's going to take a while. I'll pause here. Okay, finished. Let's see what we got. So it's under SSD export. We got another saved model, and we got another model here. Now, if we look, let's take a look at this script. In the command, there is some very important information. So graph TF2. So basically, it's export TensorFlow Lite detection saved model for conversion to TensorFlow Lite. So we still didn't get the TensorFlow Lite model, only a model that we will be able to convert. Now, one of the things that it's doing, it's setting up the input and the output for the model. So the model is going to receive single input, which is an image of float 32 bytes, and the shape of this tensor is one image, specific height and width, and we know that our model is 640 with 3 channels RGB, and it is the normalized input image. When we do run the model, we'll see how we should normalize this input. And the output, we are going to get 4 tensors. So I'll start with the last tensor, which is the num boxes, which give us the number of object that it detected, the number of boxes. Each detection is a box. So here we are going to get the number of detected boxes. And then the first tensor is going to be the actual boxes. So we are going to have, for each box, we are going to have 4 values of the minimum and maximum x and y. And then for each box, we are going to get the detection class. So what object was detected, what class. And the third tensor is the detection score for each. So for each detected object or box, we are going to have a score between 0 to 1. Okay, so the export that we did took the model and changed the input and the output to have this. So it's important to note when we are going to actually use the model. Now what we need is to convert this exported model to TensorFlow Lite. So converting to TensorFlow Lite, we can do it either by code, or we'll use we're going to use the CLI that we installed the TensorFlow. We got the TFLite convert, and here TFLite convert. Then it's really simple to run it. So if we are here, let's create um, directory for the output, and now we can do TFLite convert. The output file is going to be TFLite, and let's call it object detection model TFLite, and the saved model there. This is where the model, and remember, we are going to give it the SSD export saved model. Okay, let's see what it's doing. And finished. And if we look under TFLite, we have the OD model, which is 12 megabytes. Okay, not bad. Now I'm going to copy this. I'm going to copy this model to my Windows machine, to the TMP folder, and now let's take a look at the model using Netron. Netron is really cool application to visualize a network from many model types, not only TensorFlow. So let's open. It was here under TMP, the OD model. So it's loading the model, and you can see that we have a very nice graph. And if this is the end, and if we look here at the menu, so we can see that the input is a single float 32 single image 640 by 640 with 3 channel RGB, and we have 4 outputs. These are the outputs, and we know how to interpret the output according to what we read in the documentation about when we exported the TensorFlow model to the TensorFlow Lite conversion. Okay, so that's pretty much about it, about converting the TensorFlow Object Detection model to TensorFlow Lite. And in the next video, we are going to actually write our object detector in C++. So see you later. Bye bye.